Hey, is this live? I think it's live. Let's see. It's live. I was just watching some YouTube videos. Uh, I think he. This how we go. Hello? I was just watching some. Second, I need to switch my audio to my earphones. Hello. Is it audible? Not sure. Let's check Twitch as well. This just one time, second time streaming, so still not used to it. Uh, is it audible? Is the noise suppression working okay? I feel like the noise suppression is kind of crash. Oh, hello. It's very feeble. I'm pretty sure I have my input volume high. Wait, what? Why is it so low? Hello? Okay, that sounds better. What if I move the pop filter? Hello? Okay, this is a little bit better. I don't. The pop is not too bad, so I guess we don't need the pop filter. Okay. I'll put a little bit more gain. How about now? Let's put it like a 10 dB gain. And let's put like the noise suppression back on. What the fuck is a noise gate? Okay, okay, it's the threshold kind of thing. How do I open threshold? Let's see. It's silent now. Too much. Okay, hello. Is it audible now? Okay, this is fine, I guess. Okay, then I'll put back the noise suppression again. Hello, how is this? Okay, this sounds better. How about this one? Hello, how this? Just mic testing. Yeah, yeah, this is fine. This is fine. Okay, not so fine, I guess. Okay, I put back on the Arnon noise. How is this? I don't see much of a big difference, but okay. I'm using like 40% my GPU CPU right now. So that's pretty much the same, actually. Okay, this is fine. Oh, I have no idea what attack time, hold time, release time, what. um, I have like a very faint idea what this is, but not sure what. Anyway, okay, let's start the live stream. Okay, cool. Team, I don't know why YouTube has this issue where sometimes it doesn't it just it just sometimes just it kind of glitches out. I'll put that here. I need the Twitch chat too. And not that anybody's in the lobby, but I mean, if anybody comes, I like definitely would like to you know see what was the pop out thing. Yeah, okay, got it. Nothing. Probably like push this a little bit. Forgive me for wasting your time, but I just don't know how all this works. Okay, seems like this is a good setup. I'll push OBS. That's and then like open browser. Yeah, this sounds okay. Yeah, okay, my screen is visible. The browser is kind of visible. I guess. Okay, kind of cool, I guess. Okay, so what am I going to talk about this? Mhm. So kind of Yeah, by the way, this is my portfolio site. Just like a fun little portfolio that I made. Just having like my personal projects and like the content that I post. As I told you in the last stream, I haven't posted in a while, so yeah. Just uh, anyway. Okay. Okay, so today I kind of want to explore like local AI more a little bit more. Let's show you like what I personally use in my day to day. I like briefly touched in the last like live stream. And this time I kind of want to go to into a little bit more depth so that you can understand like what actually like what would I ideally be the best local AI setup. So currently, right now, I'm running like a local LLM model and using my like CLI agent coding tool to run like my coding. I mean, it's not my daily driver, but I do occasionally use it. Like sometimes, sometimes when my like subscription, like AI subscriptions runs out, I kind of like try to like do like light coding works locally so that I can save upon my like requests on the coding like plan. But uh unlike like in the past, coding models this time is like really well actually. I would say like it's getting actually really good. Uh like in the like past couple of years there was like mostly things stuff like Llama or like Google's Gemma, Quen, and like models tailor like the Quen 3 and like Gemma 3, the Llama 3 were all like okay. They were like, I mean, it was fine to chat with. It was like okay for like a chatbot kind of experience, but more than that, anything like if you go to some kind of like agentic workflows or if you go to like coding, they were not the best models. Okay, they had their like place. They had their place, but it's not a workhorse model. Okay, you can't get like real work done with those models. So let's see like how current generation of like local models stack up to previous kind of generations. So like artificial analysis artificial analysis is what am I doing? Damn. Yeah. Artificial analysis is like my go-to site to get like LLM benchmarks. Like just have an eagle eye perspective on like what is the best model out there. What are like your models you can use for different use cases. So like according to like if you have like a limited budget constraint and you have to get your work done, but you need to know you don't have time to like research really deep about this. Artificial analysis is a good site to know. You can get like API pricing, like how much price would you consume to get like actual work done. So that is like a few different metrics that artificial analysis actually consider in their uh benchmarks. So yeah, you can see like how fast the model is, how I forgot to record the. Oh my god, what a dumb. Fine. Okay. I forgot to what. It's not recording. Why? Okay, it's recording. Kind of forgot to record the mobile. I use that to sort of like uh post on like Instagram and like YouTube Shorts. So yeah, artificial analysis is my go-to website to. I'm just putting my phone on the wireless charger. So yeah, artificial analysis is my go-to website to get like a eagle eye view on the benchmarks of like different models. So you have like intelligence scores, speed, pricing. Pricing is actually very interesting because like you can compare how like different models stack up against each other. like in terms of price or and in terms of like speed. So like if you consider just looking at this graph, let's say like DeepSeek V4 Pro, this is like the latest DeepSeek model V4 Pro. It is like 42 points in intelligence, and like the latest Claude is like 57. Latest GPT 5.5 is like 60. But if you compare the price, like GPT 5.5 is like 11.3 out, like per million tokens out. Claude is like 10 point, like almost $11 out. But look at like DeepSeek. It is like $2, okay? $2, $2.2 like out. That is like almost 5 times cheaper than the flagship, like flagship OpenAI and Cloud models. But is it actually 5 times less intelligent? No, it is like barely, maybe like 80% there. Okay, like maybe there's like a 5 to 10% intelligence difference between the GPT v4 and like Claude or like GPT 5.5, but there's almost like a 5 times difference in price. That is crazy. So yeah, DeepSeek always gets with the best like crazy research papers out there, and when they drop a model, like everybody looks at their direction. And this is why. This is why. Like the flagship model, only the DeepSeek V4 and the flagship OpenAI model only has like maybe 5% or 10% difference in intelligence, but they have a 5x difference in price. That is crazy. DeepSeek V4 is like $2, and like GPT 5.5 is like $12. That is a crazy amount of difference. Anyway, so yeah, coming back to like local models. Mostly local models are mostly open source. So like open source models, you can mostly get like their weights so that you can run it locally. But there's a limit on what you can actually run local. There is a like a large cap on what you can run local. You cannot run like every single open source model out there on your like hardware. And the biggest limitation for the open source models that you can run is basically your GPU VRAM, because like that's where your model weights will be loaded to. That's where the computation happens. Like GPU has like the like tens of thousands of cores that you can parallelly compute the computations required to run the LLM model. So LLM models are basically like mathematical representation of like neural networks. So there will be like matrix operations going on the different calculations. So GPU having like multiple cores, like tens and thousands of cores, compared to like maybe like 10, 20, 30 cores on your CPU, can run like millions of calculations parallelized at the same time. So that's why GPUs are more efficient in doing AI tasks compared to like a CPU. And that's why you need GPU for AI. So yeah, the amount of VRAM is basically the amount of like model weights that you can keep in your basically the amount of model weights that you can use for computation. But in case of LLM, it's not only the model weights, you also need to like store something called a KV cache. KV cache is basically like your conversation or like the input and output that you send converted into, let's say, something like a vector. So it's like a tokenized vector representation of your input and output text that you send. So that will be like in a vector representation, but a key as in a key value pairs. So this will consume a lot of memory depending on like how much context it has. So like just 32,000 tokens of context would be like maybe like 1 or 2 gigabytes, but like 120k tokens would be like 5, 6, 8 gigabytes. So in that case, you also need that much additional VRAM for the KV cache. You can run it in the like RAM, but then basically your CPU has to copy all the KV cache from the system memory to the VRAM, and that is overhead on the CPU, on the bandwidth between like the RAM and the VRAM, and also on the computation of the VM. So that is a huge bottleneck to run on your CPU. So that's why maximum you actually need to run everything on VRAM. So if there is even a slight bit of like offloading to the system VRAM, it's gonna be slow. So yeah, that's the basics of like local AI inferencing. Now tell you like the best models that you can run right now on your local machine. So yeah, I'll show you like a couple of models that are like my go-to to run like basic tasks or like even coding or even agentic workflows with uh this. So let me show you like okay. So let us like clear this out and then like start from like the models that I actually really like. So one model that what did I press? Okay. I was anyway. So one model that I really like is Gemma from Google. It is like the Gemma 4 model from Google, and there's also like 4B. Yeah. Okay, these three models are the latest and greatest from the open source like labs from Google. So it's like Gemma 4 family of models. So there are like four different models from Gemma. One is there's like Gemma E4B and there's E2B. E2B is like very small, not that smart of a model. You can run it basically on your phone if you want to. Not so straightforward to run, but like Google has their official application to run. I think it's like Google AI Showcase app or something. Google AI, yeah, Google AI Edge Gallery. That's this one. It's like an open source AI application that basically you can install on your phone and use like open source Google models for basic stuff, chatting, agentic tasks and stuff like that. It's actually pretty decent. Not super intelligent, but it's actually pretty impressive because like the engineering behind it. Yeah, these are like pretty good, decent models. Gemma 431B is like a very capable model, but it's like 31 billion parameters of dense model. So basically, yeah, I've done the previous live stream about explaining what's the difference between a mixture of expert model and a dense model. So yeah, in short note, a mixture of expert model is basically like having multiple small little models of who have different expertise working together to solve a task. A dense model will be like a one huge expert model, but he will be like a general model. Oh hell. Okay, he will be like a general model who does general stuff. In case of like mixture of expert, you would have like a couple of smaller models who's like expert in one thing, and who does one thing better, and they all collaborate to give you an answer. So the 31B is a dense model. The 26B A4B is a mixture of expert model, basically like a MOE model. So these are Gemma family models. You can go to like Hugging Face and get the model weights to run it locally. So like Gemma 4. What the Gemma 4? Yeah, basically this is the Gemma 4 31B, Gemma 4 like E4B, 26B, A4B. And these are like the models that you can actually download and run. Now show you I showed you earlier how you can run these models. Like, a couple of methods. LLM Studio, Ollama, Llama CPP, even like VLL, and like anything LM. Different ways you can run this. So yeah. Mm, so these are like the Gemma family of models, and then I would say like models that I like to run. Yeah, Gemma, and there's one more, Qwen. Qwen family of models is the next best. It's not the best. It's not the next best. It is the best models that you can run on your local hardware. It is better than Gemma 4 like by far. Gemma 4 is like good, but like Qwen family models is like chef's kiss. So I'll show you. You don't need to like really. There's like a 4B model, Qwen 3.5 4B. Yeah, Qwen 3.5 and 4B is like a small model, like 4 billion parameters. If you have like a decent CPU, maybe like 6 GB VRAM or like 8 GB VRAM, you can actually run this locally pretty easily. This is like pretty standard model. The index score here is 27, and look at it, it's close to the Gemma 4 26B A4B. So it's the 4 billion parameter model, dense 4 billion parameter model is almost as good as Gemma's 26 billion parameter model. That says something about like Qwen 3.5. Actually, I want to like compare to this to like old models. Let me see, like Gemini 2. Let's see, like 2.0 Flash thinking. Yeah, 2.0 Flash. What the? You see that? This is how good the like current models are. The Qwen 3.5 4B is actually way better than Gemini 2.0 Flash. Gemini 2.0 Flash. Nobody uses Gemini 2.0 Flash now, but I remember the days where I used to have Gemini 2.0 Flash as like my workhorse model. I used to use it for like everything for my like coding, not specifically coding, but like in my like agentic workflows or like cases where I have to use LLM tools. I'm just checking if I'm like actually live streaming. I'm like kind of paranoid if I just was like rambling on and didn't have actually was not live streaming for the whole time. At least I'm recording the mobile version, so I could probably make a reels out of it. Anyway, okay, yeah, that's how good it is. Let me check the Gemini 2.5. Gemini 2.5. Gemini 2.5 Flash. I need the reasoning version. Yeah, yeah, Gemini 2.5 Flash. Yeah, there's like a maybe like a 10, maybe like a 15-20% difference between the. This was like a flagship model when it was like in 2024. That was like the flagship model. So like current 4B models, like for models that can actually run on your like laptop and your phone, is actually almost close to as good as what the flagship models were 2 years back. That's how fast open source AI is catching up. The, no, this is the biggest example of how like open source models are catching up to the like current models, and even small models are catching up to the flagship models. How good the small LLMs have become. But you can't always trust benchmarks, so you would have to like run it yourself to see like if is it actually that good. Anyway, there's the next model that I'm gonna go is the Qwen the 9B version. See that? See that? the Qwen 3.59B is only like maybe like 20-25% like as capable within the capabilities of the Gemma 31B dense model. Okay, it's not even a mixture of expert model, it's a dense model. Gemma 431B, and it's like punching almost close to that. And look at this, it is better than the 2.5 flash that was like a flagship in 2024, like the end of 2024, early 2025. Better than that. Qwen 3.5 9B is better than Gemini 2.5 flash. That says something. Okay, now then there is the Qwen 3.5 3.5 3.5 yeah, there's the you can get the 35B A3B and 27B. Where's the 27B? Yeah, 27B using. Look at that. The Qwen 3.5 27B is better than Gemini 4 31B. This is like maybe like 20-30% larger model, but still Qwen 3.5 27B beats it by clear margins. And the best part is like Gemini 4 actually came much later than Qwen 3.5. Qwen is actually currently releasing their 3.6 series of models. Gemini 4 came after Qwen 3.5, so that's how good Qwen 3.5 is. And look at this, Qwen 3.5 A35B A3B. This is again like a mixture of expert model, but it is better than the 26B A4B model, and is almost as close to the full dense version of Gemma 4 31B. That's really, really cool. Now, for the best model that you can run offline in your system completely for free, completely on your system locally, if you have a decent enough like GPU. Like if you have a decent enough GPU, I have an RTX 4070 with 12 GB of VRAM, and this is the model that I run is Qwen 3.6 35B A3B. This is the best model that you can run right now. Okay, this is like almost as good as the flagship models of like one time. I show you like a crazy spec right now. So let's see. Claude 4.5. 4.5. There's the Sonnet, Haiku, and Opus. Okay, we're gonna do Opus. Obviously be better than Opus. And then we have Sonnet and Haiku. Just look at that. Claude Sonnet 4.5 was one time the flagship model of Anthropic. And look at that. A local model that you can run on your PC right now, Qwen 3.6 35B A3B, right now on your device, if you have a good GPU, is almost as good as Claude 4.5 Sonnet. That is crazy. That is really crazy. I'll show you how good this is in a while. You know, and also let's try the GPT models. We have like the 4.0. 4.0 was like a very famous model from GPT. Let's see, this will be like the latest. 4.0 is that bad? Damn, I didn't know that. It's discontinued obviously, but like I didn't know it was that bad. Let's see. GPT 4.0. Let's see what was like 03 03 O3 Pro, O3. O3 Pro is discontinued, O3 is still around. You see that? Like the gap between that and this. It's like there's like a 5 point difference between Qwen 3.6 835E and O3. And O3 was considered like a threat to humanity level of a model when it came out. And then now we have like let's say what were the like let's see the current line of the Claude model. So let's start with the 4.6 Haiku. 4.6 Haiku. Where's the Haiku? I Haiku. Okay. Oh, there's not a 4.6 Haiku. Okay. Okay, I didn't know that. 4.6. There's only Opus. Oh, there's Sonnet. Sonnet 4.6. Uh. Okay. Let's show the adaptive reasoning. Maxable. Yeah. Sonnet is obviously clearly better than. Sonnet is obviously like clearly better. Wait, where the fuck is Sonnet that I just added? Well, this is the Sonnet. Okay. Yeah, it's almost as good as Claude 4.5 Sonnet. Where's the 4.6? Did I not add 4.6 right now? What the? There's no 4.6 Sonnet? Yeah, the. Oh, I added Opus. Okay, my bad. Right. Non reasoning. Yeah, that's reasoning. Acceptable. Yeah, Sonnet Max is. Yeah, obviously better than 4.5 Opus. But there's a 7. What? There's like a 5 point difference between these two. No, not. Yeah, what? How many points difference is that? There's like yeah, my bad. 9 point difference between these two. Like maybe like like a 20, almost like 15-20% difference between these two. And yeah, this is like flagship model that you can run right now. I mean, obviously Claude still has like better models, but like this is like a enterprise level, so like enterprise grade model that used for business use cases. And Qwen 3.6, a model that you can run on your PC right now, is actually punching near it. That's actually really cool. Coding, I think there's a difference, but core models are really clearly superior when it comes to coding. But Qwen 3.6 coming close to like O3, like OpenAI flagship, pretty cool. Agentic tasks, yeah, it's like coming close. Like 4.5 Opus, coming close, actually pretty good. One second, I gotta drink some water. Yeah, I guess you can hear me, right? You know, kind of weird when there's like just me, lonely. Anyway, okay, so that's about it. That's about the open source models. We can take a look at something else. Oh, this is the coding with different like coding tools. I kind of want to know like the reset version, like the original version. Clear- Oh, what the? No, it's not the. Damn. Wait, come on. Ooh, okay. Loading everything is not obviously the good idea because of just lag like hell right now. Okay, is this the original models that they have in selection? Oh shit. Okay, wait, what? No, I don't want reset. Yeah, reset default. This is like pretty CPU intensive. Like it just boost all of a sudden, and your performance is just dead. Looking at the index. Okay, Opus 4. I kind of am skeptical about this, to be honest. Like, every time I like open Twitter, it is like half of the people complaining that Opus 4.7 is not as good as Opus 4.6. I don't know why. I personally haven't tried it because I didn't subscribe to the like the Claude coding plan. Like the Claude plan, $20. I think like $20 and $200 plan. I'm not that eager to waste my money on like take stuff that I probably like won't be using like it to its full potential. Because like I have anyway like Copilot subscription in my work, and I don't need that much power like a powerful model in my like personal projects anyway. So actually kind of cool. GLM 5.1 is like Cloud Code with GLM 5.1. Can you run like third party tools on Cloud Code? I think like yeah, I think you can. I haven't tried like Cloud Code personally. Can't say about that. My jaw is kind of paining doing all the talking. And I told you I'm not like super super experienced with the like live streaming. This is like my second live stream of my life, so cannot my thing. I mean, I'm just experimenting at this point. I'm not sure even like I'll continue like live streaming like for a long time. I'm just experimenting. Uh, yeah, let's explore like the best ways you can actually use these local models. So my go-to tool for using uh the local models is Llama CPP. But yeah, Llama CPP is, in my opinion, the best way that you can run local models on your device and use it for coding. So Llama CPP is basically like a inference engine that you can use to like serve up an OpenAI API compatible, like OpenAI endpoint compatible server on your local machine, or you can even use it as like a CLI tool. But in most cases, you generally want to have like an HTTP server running with like the OpenAI endpoints of the model that you want to serve. So basically, most tools, whether it be it like CLI tools or like Cursor or like any tools that usually use like AI, like LLMs in the backend, usually have compatibility for the OpenAI standard. So yeah, Llama CPP is basically running like an OpenAI standard Llama server. So yeah, it is like crazy easy to set it up. Like all you gotta do is like you download um, the executable for your specific distribution or like operating system. If it's Windows, you can download whatever you want. Like if you have like NVIDIA GPU, these two works pretty well. If you have like AMD GPU, this is one that you want to download. If you don't have like AMD or NVIDIA, you probably like need to download these. If it's like a if you have like a Snapdragon laptop, then probably the ARM 64 is the one for you. If you have like an Intel or like an AMD CPU only laptop, if you don't have like GPU, this is the one you get download. There are use cases for like running only on CPU. Maybe like a 1B model or like a 2B model can easily run on your like GPU, even your CPU and your like system memory. And it can actually do like things like autocomplete on your IDE or like basic writing, dictation, translation. Like even the small like 1B models are like really good for translations between like languages, any languages in fact. Wait, what the hell? How the hell do you run an R? Oh, it's probably for the Termix. Yeah, that's another video. Of like how to set it up for an Android phone. I'll probably show it in the future. Not right now. I don't have like the patience and the like mood to do it for now. But yeah, eventually one day I'll probably do it. Yeah, so I'll show you how you can like set it up. How I set it up. So basically, like first of all, I personally, what I did is like I cloned the repo and like built it from scratch. So if I go to like the fuck are the tools? Yeah, tools. So yeah, not tools. It was dev tools. Okay. Yeah, in dev tools I have like the cloned the Llama CPP thingy. Yeah, Llama CPP server. All you gotta do is like I'll show you the command. I've saved it actually. So, yeah. So we'll like just have a look at how you know how like start it up. This still yeah. Okay, so we can do. Um, so yeah, this is the like go to command that I do. Let's just not do this right now. Okay, and for the Llama server, we need to make the Llama server from this. I'll show you what this original command actually does. I showed it in like the previous thingy. previous like live stream. But yeah, this is what it is. But did I not build for long? I think I didn't build. Oh shit. I mean, I can build it, but like, do I really need to? Pretty straightforward doing it. It's like, where's the building? Yeah. Oh, Google binary and build from source. Yeah, just a build guide. You can like build for different devices. I have like NVIDIA GPU, so I do the CUDA version. So you basically like do CMake build, set CUDA on, and just like build. That's pretty much it. It builds to like the build directory as Llama server, Llama CLI, and I think also the benchmark tool as well. It just um, serves it up. I mean, it builds it up. So yeah, after building, you get a tool. And actually, I want to show you one more thing. This is the Turbo Quant version. So there's the Datom Turbo Quant. Turbo. So this is a Llama CPP fork made by a guy called Atom. He basically did like implemented Turbo Quant for Llama CPP in this repo. There is the official like PR, a race for like merging Turbo Quant into the Llama like upstream. Still not merged, I guess. Like whoa, what is this? Methodological AI viewers streamboo.com. Is it like a I don't know what that is, but it's just a small link, so probably won't get me killed. Oh, okay. Yeah, I'm not going to. Let's see. What is this? Oh, while scrolling in the moderation view to report him, accidentally click on the set link since the link was chat was scrolling. The link was a cuddly link redirecting first via discount arena, okay, and then to the wanted site. It's called like Streambo. Nothing to download to my PC. Okay, so yeah, this is a malicious ban. Okay, I'm gonna ban you, buddy. And I'm pretty 100% sure like you are a bot, but yeah, I don't want you guys here. Sorry, my bad. I mean, not my bad. Your bad. Okay. Yeah, I mean, it's like pretty new to me, but yeah, you guys are not welcome here. Everybody's saying like a scam, 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 scam. You are definitely a scam. I'm not going to you, bro. Okay. Bye bye. Yeah. What is this? Turn on shield mode. What does turning on shield mode come? I don't know what that does. Okay. Oh. I mean, nobody's watching, so I probably won't be needing any content moderation at the point. So yeah, yeah, this guy basically implemented Turbo Quant for Llama CPP, and this is a fork that he made of Llama CPP. So I run all my models from here. So that way, a Llama C like Turbo Quant basically like compresses your KV cache, so that your KV or like your context doesn't like need that much VRAM. It like compresses up to like up to 80%. So like something like 8 gigabytes now becomes like 2 gigabytes. I mean, it's not always that like big of a compression, but yeah, you can definitely do that much in like some scenarios. I've observed like changes up to like 50, like 60% myself. So yeah, this is my go-to place to run. I'll show you like uh yeah, you can basically like this is the command. We can break it down. This is like the command to run the 9B model. So yeah, basically the Llama server from the Turbo Quant CUDA version that he made. And this dash m is the model file. So this is the model file that I have. This is a 9B uncensored model that I downloaded from Hugging Face. And then the mmproj. Mmproj is basically like a vision decoder. So this having the mmproj file for your Llama model basically gives you vision capabilities, or like basically like it is a vision encoder that converts your like vision, your like images, the pixels of your images into like token vector token representations that can be stored in your KV cache. So that's what that does. And this is the settings for turning on Turbo Quant in your like in this particular fork. So cache type K for the key, that is Turbo 3. This is like different levels of quantization by Turbo Quant. So like 3 Turbo 3 is like the third level of quantization. There is like 2 and 3 and 4. So 3 is what I observe to be like the most like stable performance and like the ideal VRAM. There's like a very minimal loss in quality when you compare it to like the full size, but yeah. And this is the for the V, like the value. NGL is like the offloading. I think it's like GPU to like CPU offloading, yeah, offloading to the GPU. So basically, like you're telling it to like offload as much layers into the GPU as you can. So basically, like giving a higher value mean like the most amount of layers that you're uploading to the VRAM of your GPU. So yeah, C is the context size. So here we are giving it like 256K of context. Host basically like your local IP, like the system like local host. Port, pretty straightforward. Flash attention. This is like flash attention is like a very complex topic, to be honest. Like I don't even understand it fully myself, so I won't be like a great guy to explain this to you. But basically it is like attention is like how much the model like weighs each token in your context. So like how much importance does it give? That is basically like attention. So flash attention is like a process to speed it up. I don't know the entire like technical details, but that is essentially what it is. And Jinja is a chat template. So there is like instruct, there is the normal like model, then there's like the chat models. So each have like a template on how it should respond and how it like the user should respond. Essentially, like the model starts from a token, then the model response should end on a specific token, and response should be encoded in like coded in a specific token, stuff like that. That is basically like the chat template, and Jinja is like a library or like a framework for chat, like making chat templates. That's essentially what it is. Okay, what the hell is that supposed to be? Why is it not running? What the heck? This is supposed to run pretty decently. Oh yeah, I'm already in DevTools, that's right. Okay. Mm. Oh yeah, I deleted this model by the way, so I forgot about it. Yeah, I deleted this model because like I know I have better models, so I just don't use it, so I need to save my space, so kind of deleted that. But why don't we just go to the big guns? Yeah, let's go straight to the Qwen 3.6 35B. Yeah, takes a while to like load it up and like starts the server and stuff like that. Takes a bit, but like generally it doesn't take like that long. So yeah, it's currently running right now. Yeah, this is what the it has like a micro front end for the server for the like the inference. Basically, serves up like an HTML page for you to like run your like chat. Simple, very simple. Like there are like chats. There is basically like conversations, and then there's like a basic setting. You know what are the temperature, what are like the different parameters that you need to set for the like model, stuff like that. Like very basic. But like, I'm surprised it has MCP support. Yeah, I mean you can definitely like chat and get work done with this, like for sure. Yeah, we can try like maybe let's say. Uh, yeah, I can show you what is what is attention in attention in large language model. Language. Okay, I'm getting like 23, 23 tokens, I guess. It is usually around like the 30 tokens per second mark, and this is probably due to like me streaming, and I'm already using like 30-40% of my CPU and like GPU for the video encoding and stuff like that. Probably because of that, the speed is like less. Usually it's like much higher. Let's see what this says. Okay, my back is kind of killing me to be honest. Oh damn. Attention. Self-attention is the core mechanism that allows modern large language models to understand context, base the importance of different words, and generate coherent human-like text. It is the central innovation of transformer architecture. Yeah, this is the original paper by Google, by the way, which replaced the older recurrent models like RNN and LSTMs. Yeah, I don't know. I forgot what LSTMs were. Let's uh let's search what are LSTMs. Long short-term memory. Okay. Okay. I'm like very like like vaguely familiar with it. I'm not sure like I don't even know I don't even know the full form, but like I've heard about it. Yeah, this core idea is like processing one by word. Instead of processing one by word or assigning fixed importance to the position, attention lets the model dynamically focus on the most relevant parts of the like input sequence when producing each output token. So this like learns to pay attention to the word. Yeah. So it basically uses like crazy maths around like math in the background and like does stuff. That's all you need to know, I guess. How many how much time did I spend? Like I'm like 15 minutes in, like yeah, about 1 hour into the live stream. It's like 1 hour. Yeah, yeah, almost 1 hour, 1 hour to 5 minutes. So I'll probably end before like 1:30. Yeah, that's pretty much it. But yeah, the crazy part is like I'm running Quen 3.6 with yeah, running Quen 32. I'm running Quen 3.6 35B. Oh, and I'm getting like 21 tokens per second. Usually gets around like 30 tokens. Currently not getting because I'm streaming. Yeah, but the important thing to note about here is like this. I'm using like quantized version, so this is like 4-bit quantized version of the model, which means it's not the full entire weight. So let's see what like quantization is. Model quantization. Model quantization. I'll explain to you what quantization is. I'm looking for like the a good picture that I can show you actually. Like I know the basic principles of quantization, like what exactly happens, but I want to like show you. Yeah, I guess you can do that. So let's see. Let's see the differences between different types of model quantization. Model quantization. Let's see the quality comparison between the like model quantization quality comparison. I actually saw like a very good graph between like the quality between the each of the accuracy. Not the one. It's only like a very clean example. Yeah, dude, I'm not a robot. Like, what the fuck are you talking? Yeah, this stone. Yeah, this is essentially the what I'm talking about. Yeah. So yeah, what exactly is quantization? So what is quantization? Now, quantization is the process of like representing the model weights in like a lower precision while maintaining the like high accuracy or like the properties of the model. Is that how that how you phrase it? Like, what exactly? Okay, you can yeah, you can essentially summarize the process of quantization as saying that you're trying to reduce the size of the LLM model while maintaining its accuracy. So essentially, there are like a couple of different types of quantization. Essentially, what quantization is, the the model weights are actually a set of like really large numbers. It can be like a very from like a very negative number to zero to like a very high positive number, and it's in like a vector space. So it's like a directional. This is too complicated to explain in like simple terms. Okay, is there like a better diagram? Yeah, this is the best diagram, I think. Okay, so yeah, essentially the model weights are like a set of numbers represented in vectors. So these are like positive numbers to like negative numbers, and these will be like very high precision numbers. So by that mean it will be like a decimal points of numbers with like very high precision. So like 1 point to like a next 10 like values. So what essentially happens when you quantize the model is that the model numbers are tried to be you try to represent the model numbers in as little like space as possible. So in like full precision, it will be like a 32-bit number. So that is like 32 bits of bits of like yeah, in full precision, a model would be something like a floating point 32-bit number. So it would be like a decimal that is represented in 32 bits. Now you can compress it into like let's say something like int4. That would be like 2 bytes, 4 places of 2 bytes, so like 8 bits. What the fuck? No, it's like 8 bits. Yeah. Okay. So yeah, I'm like just trying to recollect it. So okay, the model weights in full precision would be like represented in like floating point 32 bits. So it would be like 32 bits trying to represent like a decimal number. So it would be like let's say like 10.3656 something like that. But it uses like 32 bits of memory to represent that single number. And the model will be like a billion or like places of these numbers, like a billion set of these numbers. When you essentially quantize is like the model parameters, which are these numbers, are essentially like represented in like less space. So something like q4 or like q8 in4, these are like quantizations that is like when you compare like in4, the 32 bits of the like representation is now reduced into like a 8-bit a number. So that would be something like, represented when you study like binary representations. It would be like 1011 1011 or something like that in like 8 bits. That's how you represent. So by that, you are essentially like trying to represent the whole like parameters of a model with as much less space as possible. So yeah, of course you lose some precision in those numbers. So in this case, like something like 15.5555678 will probably be represented in like the quantized Q4 as just 15. So yeah, you essentially lose that like decimal point of a precision, but in this case, you get like the actual 15 representation. So in most cases, that's actually pretty more than good enough. But yeah, you essentially lose some precision. So Onslaught is like a very popular. So yeah, yeah. So Onslaught is a very popular library that you can use to quantize your models, and like dynamic quantization is something that they introduce. So essentially, like they have like a study comparing the quality of the like different models at different quantization. And if you look at this, you can see that the quantization, when the quantization is like very small, it's like very imprecise, and it climbs up when you have when you go towards more precision. Yeah. Yeah, essentially like yeah, essentially the lower the quantization, the lower the model quality, the higher the quantization, the higher the model quality. But the difference is it is not like a very straight like linear progression towards the quantization, because if you look at the graph, like it only starts dripping very low after the 2 like 2k. Q2 is like the point where it really drops sharply. Before that, it's like a very gradual slope. So I'd say something like Q4 is the best of the both worlds, because there's a really like large difference in memory between the Q4 and the Q8 and like Q5 and Q6. Oh, like that would be the difference between you being able to fit a model in like 12 GB of VRAM versus something like 24 GB of VRAM. I'll show you the example. So if you look at like maybe like Qwen 3.59B, maybe unsensor version. Let's see, like Qwen. The unslot version. Yeah, if you look at this, the unslot has like a whole lot of different quantization available. But if you look at this, even if it's like a 9B model, it's like a small, very small model. Like, look at this, 16-bit like BF8, BF B. The 16-bit quantization of BF16 is 18 gigabytes. You can't fit that in like a 12 GB VRAM. You need at least like 24 gigs of VRAM to fit it. But look at the Q4. The Q4KM, which is like the best version of the 4-bit quantization in terms of memory, that is like almost 6 gigabytes. Look at the difference. The 4-bit quantization is almost the third of the size of the like 16-bit quantization. But look at the like quality difference. Q4 is like barely like 1 or 2%, or like maybe like the worst case scenario 5% worse than the Q8, or like yeah, the F16 B16 would be a slight better, but yeah, Q8 like Q4 at the worst case scenario is like maybe 5 to 10% like worse than the Q8. But like if you just compare the size difference, like Q8 is like 10 gigabytes, Q4 is like 5.5 gigabytes. That's like 50% difference in size. So you can easily fit a 5 gigabyte model in your like 12 GB VRAM, or like if you try hard enough with like small context, you can even fit it in like 6 GB VRAM. That's like running of 9B model in like a 30, like in like a 10, like yeah, in like a 1080 Ti. 1080 Ti is like, 6 7 years old at this point. 1080 Ti is like, even when did 1080 Ti come out? 1080 Ti. 1080 Ti. When did 1080 Ti release date? 2070. That's almost four, yeah, that's almost like 10 years old. Yeah, 1080 Ti is a decade old, and that can run like a 9B model. And you saw like how powerful a 9B model is like at this time. That's how powerful it is. So yeah, that's about the quantization. Oh man, I've been rambling on for a while now. How much time is it now? Yeah. Oh, probably like stop. I still didn't show you the local coding setup. Yeah, I can. Probably on the next Tuesday or something. By then, I'll probably like edit up these live stream to like smaller clips, so that I can post it on uh, like Instagram or like YouTube Shorts, and like drive up some traffic so that I can actually get some viewers here. Anyway, honestly, I kind of like feels it's a bit refreshing actually, like talking without a script. You can like really just talk. But yeah, when you like cut it up into shorts, it's not that high quality because like you're just rambling and you just have like random clips of you just talking. Anyway, probably stop right now. Yeah, I'm feeling a bit tired to be honest. Like, yeah, that's about it. So yeah, I'm gonna stop now. Take some rest and go to sleep. It's like 10:45 here in India. Yeah, bye.